All right, so now we are factoring trinomials. Got 3 terms. We factored binomials first. Trinomials, we got 3 terms. When a is 1, so I'm saying a because this is in the form of ax squared plus bx plus c. Okay, for in general. I mean, I know this one has a 4th on it, but we'll get there in a second. So when a is 1, this factoring, super easy. Okay, you don't have to overthink things. The first thing that you can actually do is write down 2 little parentheses, because you don't have to really do anything else as far as your answer is concerned. You might need to do some stuff off to the side, but remember, what's going to hinder you the most in factoring is not knowing your multiplication facts, because then you don't know how to combine numbers and stuff. Yes, I forgot to start a timer for that quiz. Okay. So here, if this is m squared, I know this is going to be m and m. Here are some other thoughts that you can have before you start worrying about numbers, because the numbers are what can mess you up here. If c is negative, that you're going to get this number by multiplying these 2 things together, right? So if this is negative, that means the signs inside of here have to be opposite. That's the only way you're going to get a negative, right? If it's positive, it's either positive, positive, or negative, negative. Thank you. So the way I like to think about this is I look at the fact that this is negative, and so I know my signs are opposite. And then that helps me with my numbers also. I need 2 numbers that multiply to give me 30 and combine to give me a negative 13, and the signs have to be opposite. 10 and 3. Will that work? Negative 15 and 2. And I picked this question in particular because I think the first thing in everybody's mind, mine included, is 10 times 3. Because 10 times 3 is 30, and 3 plus 10 is 13, right? But if I put those in here, I would have and it would either be a 7 or a negative 7 when I combine them, right? Does that make sense? Okay. Why is this empty? Anyway, looking over here sketchy. You were just getting that out, I know, but why is this empty? 4 phones. Let's go. Everybody, phones. I shouldn't have to say it. What don't you do? Why are you in your computer? Close your computer. Where are your notes from yesterday? All right. So what were the numbers then? I'm sorry. 15 and 2, right? And then to decide where they were, because some of y'all were giving me the signs too. This sign is negative, which means the bigger number is negative. So 15 and 2. And then always, especially because the 10 and 3 thing over here, always double check yourself that when I combine these 2, I'm going to get a negative 13. And when I multiply them, I'm going to get a negative 30. And we're good to go. Okay? Does that make sense to you? We good? All right. Now, this is x to the 4th. It does not make it any more difficult. Even though I'm saying that, when I give y'all a quiz or something on this, some of y'all are going to make up math. You're going to stare at it. You're going to think it's the hardest thing you've ever done. If this was m squared, and this is m and m, this is x to the 4th, what do you think goes here and here? X squared, exactly. All right, that's a negative 20, which means my signs are opposite. Now I need 2 numbers that multiply to give me 20, but then subtract, basically, because that's negative, subtract to give me a negative 1. What are those numbers? Positive 4 and negative 5. Okay, so even if it just at first you get like 4 and 5 in your brain, you get this is 5, this is 4. Okay, we good? This should be kind of a no-brainer here for sure. Can I factor that one anymore? No, because we have a difference of squares we talked about yesterday. Remember, there's no such thing as a sum of squares. X squared plus 4, I cannot factor it anymore. This 5 is not a perfect square, so I can't factor that anymore. All right, so if the signs were switched, then yes, I could go another step, which we'll do some of those. But here, I can't do anything else. Okay, everybody good on that? Because this is x to the 4th. So when I multiply it back together, I'm going to get x squared times x squared is x to the 4th. Okay, does that make sense? And then I'd have a positive 4x squared, negative 5x squared, and that's where I get my negative x squared there. Thank you for asking. Always ask if you're not sure. Anything else? All right, so now we have one where a is not 1, a is 2. We try first always to factor out a GCF. Can I factor out a GCF? No. Wish I could, but I can't, right? We can't make stuff up. So there are different ways to handle this. But I feel like the general, and I've reviewed it many different ways over the years, depending on what the trend is for how people are teaching it at this point. But I think the majority of you probably learned grouping, and even if you didn't, that is the best way to do it, even though I know that's an opinion, because it works for things that are not trinomials. So you got to understand grouping anyway. So what we do is we start off by multiplying 2 times -7, and we get -14. Okay. So before, when we were looking for two numbers that multiply to give me 30 and combine to give me -13, I'm basically ignoring the 7, and I need two numbers that multiply to give me -14 and combine to give me a -13. -14 and 1. Okay. So then we do grouping. And with the grouping, what we're doing is we're splitting this term. So we write down 2d squared. And then we just decided it was -14. So -14d plus d. So that this together would give me that. All I did was split that term. We all good with that? And then -7. Okay, so now I factor by grouping. I probably shouldn't have done that little squiggly thing there. Let me erase the little squiggly there. That's D right there. So now I'm going to factor by grouping. I group those two together. What can I factor out of that? 2d times, and that's d minus 7, right? Now out of these two, technically I can't factor anything out, and really if we're factoring out a GCF, we never factor out 1. But when you are factoring by grouping, you got to factor that 1 out or things aren't going to work out. So I factor out a 1 because that's all I can do because it makes a difference, and that leaves me with d minus 7. When you get to this step, these two things should match. If they don't, either you did something wrong or you can't actually factor this one by grouping, okay? Or you can't factor it. So now we put this stuff all together. I've got this 2d plus 1 times d minus 7. That is fully factored. That is not, which a lot of you want to stop there. That is actually factored. Okay, we good with that? Now, if you prefer the box method or whatever weird thing your teacher might have taught you, or back in my day, it was guess and check and just hope you can figure it out. But I don't care. I'm not saying you have to do it my way, but if you don't really have a way that you're really latched onto, this is what you need to latch onto. Okay, we good? All right. So here, once again, I have something to the 4th. So I'm not going to freak out. I'm not going to make up math. I have q to the 4th and then q squared, so it's still set up like a quadratic, even though it's not a quadratic. It's set up in the same form. I'm going to multiply 4 times 9 because I cannot factor out a GCF. That gives me 36. Okay. Now, since the 9 is positive, the two signs that are in here are going to be the same. They're either positive, positive, or negative, negative. Since this is negative, what are they going to be? Negative, negative, right? So I know that all I'm doing now is splitting this term. So I can go ahead and write down 4q to the 4th. And then I need two numbers that multiply to give me 36, but combine to give me 13. 9 and 4, right? Okay, so I heard -9 first, so -9 q squared, and then -4 q squared plus 9. And then you just make sure the term you split, when you combine it back together, you're actually going to get what was right there. Because checking yourself along the way, that's what will keep you from getting weird, crazy stuff that you don't even know how you got it in the end. Now we factor by grouping. Out of these two, what can I factor out? 2q squared. And then that leaves me, oh, not 2q squared. I'm sorry. I think y'all said q and I made up a 2. I'm sorry. So q squared, yes, that's the only thing I can do. And then that leaves me with 4q squared minus 9. Out of those two, I have to factor out the negative. So I factor out a -1. And then that leaves me with 4q squared minus 9. And my parentheses match, right? Which is one thing that I have to make sure happens before I can go any farther. So that leaves me with q squared minus 1 times 4q squared minus 9. Where? Oh my gosh. Where? I don't. Oh, no. No, that's right. Y'all make me second guess myself. Where did I get what from? Say it again, because the 1. I get, it's from this. This is q squared minus 1. That's where that came from. That's why here, this 2d plus 1, that's where that came from. Oh, where am I getting this from? Because this is q squared, it's not q. This is q to the 4th, this is q squared. Okay, now I see what y'all are asking me. It's because I messed up once, I was assuming everything else I did was wrong. Sorry. That's why I was like, crap, what did I do again? So yeah, that's why these are q squareds. Does that make sense to you? Okay, we good on that then? Yes, absolutely. Because technically what you're doing is you have these two big terms right here, and you're factoring out the parentheses. So if you put this one first, if that's what you normally do, that's totally fine. You just mean like flip-flop the places here? Oh, absolutely. Yes. This one? Because out of these two terms, I factored out a -1. If I don't factor out the -1 and I leave it -4q squared plus 9, then it doesn't match this. So if this term is negative, you have to factor the negative out. So when I factored the negative out, that made this positive and this negative. Okay? Everybody with me now? What else do I need to clear up before we move on? Don't be afraid to ask. Okay, so we're all good with where everything came from. And what the other question that I don't know if everybody heard was, here, could I have put 4q squared here and 9q squared here? Absolutely. Then this step for you would look a little bit different, but that's okay, because in the end, we would be the same, okay? Doesn't really matter, whatever. Okay, everybody good now? Okay, so now I have factored it into two binomials, but can I factor this one more? Yes, because this right here, is that a difference of squares? Yes, so this can become q plus 1 times q minus 1. And then this is also a difference of squares. So what would my first term here be? 2q plus 3, good. And then 2q minus 3. Okay. So if it's a quartic, okay, quadratic to the second power, quartic to the fourth power, on this one, once we got here, we were able to factor more just because of the answers we got. Here, I had a quartic, but once I got to the two quadratics, I couldn't factor it anymore. And it's possible maybe you get to a point like this and you could factor one of them, but not the other. Okay, you can't, it doesn't necessarily always have to be everything. Okay, what questions we got? We good? Okay, let me take y'all's quizzes so I don't forget. Thank you. All right, so everybody good on those so far? All right, so the trinomials when a is 1, trinomials when a is not 1. Now, then we get to 4 terms, no longer a trinomial. Okay, we've got 4 terms here. This, I think sometimes people think means it's more difficult. It's actually easier. I just realized my variables are completely gone there, and I don't know why. Well, we'll get to that one in a second. They're like ghost variables over there. But this is, we're going to factor by grouping. It's actually easier than the one above, because notice we took this and we had 3 terms. We changed it to 4 terms so that we could do the rest. Basically, this is just starting me at this step so I don't have to make those decisions. Okay? Now, is every 4-term equation or expression going to be factorable? Not necessarily, but we got to see if we can factor them. So I already have 4 terms. We make sure they're in order. They should be in order for you. And then we just start with the factor by grouping part. Out of these 2 terms, what can I factor out? H squared. Okay? And that leaves me with 2h minus 3. What can I factor out of the next little 2's? A 3. So this will be, and it's a positive 3, right? Don't forget the sign there. Plus 3. Then this is 2h minus 3. Then I'm good. I'm on the right track because my parentheses match, right? Then I'm going to get h squared plus 3 times 2h minus 3. And can I factor it anymore? No. If I could, the only one that would be more factorable would be this one, but it's not factorable, so I am done. Okay? Any questions on that? All right. On 22, I don't know what the variable was supposed to be, but let's just put an x in there. So it should be x cubed and x squared. I don't know why. Sometimes things just, poof, they're gone. Oh, and then this would be an x right here. So we're going to factor by grouping. I group these two together, and I can factor out a what? X squared leaves me with x plus 7. Out of these two, what can I factor out? Negative 5. Good. And then that leaves me with x plus 7. So then my parentheses match. That's a good thing. Then I end up with x squared minus 5 times x plus 7. Can I factor this anymore? No. This is a difference, but it's not a difference of perfect squares. So again, I'm stuck. Okay. What questions do you have? Anything? Okay. Now, besides the exponents and all that stuff, what's one big difference between 21 and 25? It's equal to. This is an equation because it has an equal sign. This is not. Notice how I'm stopping here. I didn't say h equals whatever because I can't solve it because it's not an equation. If I have an equation, you could be asked to do two different things. It could just be completely factor the equation, or it could be to solve the equation. Either way, you got to completely factor it first, okay? So let's go ahead and factor this first. One of the things that I didn't have you check on all the others, and it's just because I knew it wasn't going to happen, but I should have said it, is we always check first to see if we can factor out a GCF, okay? First of all, before you start factoring anything, you make sure it's set equal to 0. We're good. Can I factor out a GCF? Yes. What would my GCF be? 5n, right? 5n. 5 would just be the CF. I need the GCF, right? So that leaves me with n to the 4th minus, what's 80 divided by 5? 16. And then I still have equals 0. You do not get to willy-nilly do random stuff and not keep your, otherwise you have a linkage error. If you drop off equal signs or you just randomly do this part and nothing really links together, you're not getting credit for any of that. Somebody's got to be able to follow what you're doing step by step, and your step by step has to make sense mathematically. So you have to rewrite everything. So now this guy's just along for the ride, but I can't drop him off. And I can't drop this off either, but I need to factor this. Is this a difference of squares? Yes. So I still have this 5n. That n to the 4th minus 16 will give me 2 binomials, and then I'll still have n equals 0. The square root of n to the 4th is n squared. Square root of 16 is 4. So I get n squared plus 4. N squared minus 4. Okay, difference of squares. Everybody with me? All right, now, can't do anything else with this guy. He's along for the ride. Can I factor this anymore? No, because there is no sum of squares, right? Can I factor this some more? Yes, so this is going to be a change, but everything else stays the same. So I write 5n times n squared plus 4. Then this is going to become 2 binomials, and then I have equals 0. Square root of n squared is n. Square root of 4 is 2. So I have n plus 2, n minus 2. And that's equal to 0. Everybody with me so far? All right. And I just realized I redid this and I had some room off to the side where we did some stuff and I don't have the room for that anymore. We're going to solve this and we might have to write some stuff up here and up here where we have the room. So that means I set each one of these equal to 0. I'm going to set 5n equal to 0, which means n equals what? 0. I set n squared plus 4 equal to 0. So that means, and even though I'm going to have to break y'all of boxing your answers because we can't box our answers in AP. I'm going to box them on this one. Otherwise, we might lose everything that we're doing because it's in a tiny little box. Okay. So there's one of my answers just so we can find it. So if I'm going to solve, this would be n squared equals -4. When I take the square root of both sides, if you introduce a square root, what do you have to make sure is there? It's just any square root ever. What do you have to, how many answers are you going to get? 2. So what do I have to write down first? Plus or minus. Plus or minus, right? Otherwise you end up in math jail. And then the square root of 4 is what? 2. But since that's negative, what do I put after the 2? I heard it. Bless you. I. There we go. Okay. So I've got this. I took care of this. Now I got these two. I'm going to get n plus 2 equals 0. So n equals -2. And then n minus 2 equals 0. N equals 2. So this was a 5th degree polynomial. I have 1, 2, 3, 4, 5 zeros, but only 3 real zeros. So if I were to graph it, I would only be intersecting or touching the x-axis at 3 points, right? And most of the time we're not, every now and then we talk about the imaginary ones. I want to just go ahead and throw that one in here right now, but we'll talk a little bit more about when we can just not even worry about those. But everybody good so far? Oh, questions about anything? Because it's starting off right here into the 5th. Okay, so that tells me I have 5 solutions no matter what. I have at most 5 real solutions, and really when we're graphing and doing things like that, we really only look at the real ones. Again, there's a time and place for the imaginary stuff, which we will talk about. But if I'm talking about graphically, how many zeros, how many real zeros do I have? I have 3 real zeros and 2 imaginary zeros for a total of 5. The total will always be 5 of the imaginary and the real ones. Okay, everybody good with that? And also I'm going to throw this in there. Notice that we got this because we were taking the square root of a negative, right? Which means anytime I do that and I take the square root, I'll have a plus or minus. So if you have an imaginary 0, a non-real 0, they come in pairs. They have to because you're going to end up with that plus or minus. So either I have 5 real zeros, or I have 3 real zeros, or I have 1 real 0. It would be impossible here for me to have 4 because these don't live alone. I mean, we'll get more into that, but I just at least wanted to throw it out. My board does weird things sometimes. There we go. All right, everybody good so far? All right, so number 26. Before I do anything, what do I need to do first? Set it equal to 0. Exactly. Now, I could move over the 4, and that would be fine. But I personally think it's a lot easier when we keep our leading term positive, right? So instead of moving the 4, I think I want to move the other 2 terms to the right. You with me on that? That way just those are positive. Okay, so we are going to have 0 equals 6k squared plus 14k plus 4. Now, I could have, even if I move the 4 to the left, I could have factored out like a -1, and that'd be okay too. But then you have to hang on to it, and it's extra stuff, so whatever. We'd end up with the same answers in the end. I know, because I moved everything to the right. So I added these to this side instead of moving it the other way. Everybody good? Then what's the next thing I should check for? Greatest common factor. Because I could factor this without factoring out the GCF, and I could get the same solutions in the end. However, my numbers are going to be bigger and yuckier. So I'd rather not have bigger, yuckier numbers if I can handle it. Or if I can help it. What is my GCF? 2. So then that leaves me with 3k squared plus 7k plus 2. Okay. Now that 2, he's along for the ride the whole time. I can't forget about him. I can't drop him off. Nothing like that. He stays with us. Just tags along. So I'm going to just look at this because that's what I'm trying to factor now, right? 3 times 2 is going to give me 6, positive 6. So I need 2 numbers that multiply to give me 6, combine to give me 7. Okay, 6 and 1. Would they be negative or would they be positive? They'd be positive. So the signs are the same because, so it's either negative, negative, or positive, positive because of that. Since this is positive, it'd have to be positive, positive. Okay? All right. And even if you move the 4 to the other side, at this point, they would still be positive because we would have had to factor out the negative to keep that first one positive. All right. So now I'm going to take 0. Oops. I'm going to have 0 equals. This 2 is still right here. My next step is to split that 7. So I'm writing 3k squared. And then plus, do you want to do 6 or 1 first? 6. Okay. Plus 6k plus k plus 2. All right, everybody okay with that? So now I'm going to factor it by grouping. I'm going to group these 2 together and these 2 together. And I'm going to add, now I could just add extra parentheses, but I'm going to change the parentheses I have to brackets so it makes a little bit more sense visually. I get 0 equals 2, big old bracket. Out of these 2 terms, I can factor out a 3k. That leaves me with k plus 2. Out of these 2, what do I factor out? 1. So it's plus 1. And then I have k plus 2. Do you see how making the brackets brackets and not parentheses kind of helps you keep track of things? And then after this, I can drop those brackets. This will give me 0 equals. So I got 2 times. So I have this 3k plus 1 times k plus 2. And I have it completely factored. Now, this was a second degree polynomial. It's a quadratic. So I'm going to have how many total zeros, real and imaginary? 2. So do I get a 0 from this guy? No. There's no variable on it. If that was 2k, then I would have a k equals 0. We can't forget that either. But that's just a 2. He ain't helping me. Now, I wrote all this stuff out and made little equations. It's okay if you don't make little equations. It's okay if you can just get to that here. You'll get your phone? Yeah, oh, yeah, you left it. Yes, yes, absolutely. I could actually write those out, or I know that k plus 2 is going to give me a negative 2. And what would that give me? Negative 1/3. So if you don't need to write them out and you can get the right answers, that's fine. If you want to or need to write out 3k plus 1 equals 0, then that gives me 3k equals 1. I hope you feel better. And then, oh, negative 1. And then k equals negative 1/3. That's where it's coming from. You know whether or not you need to write this out. And I think there's always people that don't necessarily need to, but they want to because they don't want to mess up, and they do, and that's absolutely fine. But as long as you get to the fully factored, then you can get the answer, you're good. Okay? What questions we got? Anything? All right. So let's look at 28. I need to do what first? Yeah, set it equal to 0. So, and I would move the 6, absolutely. So 0 equals 6n squared, because I'm adding that, plus 8n. Can I factor this at all? Yes. What can I factor out? 2n. So I'm going to factor out a 2n. That leaves me with n plus 4. 3. Oh my God. Thank you. Oy, oy, oy. 3n. I'll see if you're paying attention. Plus 4. Now, how many total zeros will I have? 2. Is this guy important this time? Yes, there he was just a 2. Here's he's a 2n. So that's technically 2n equals 0, which means n equals 0, right? And then 3n plus 4 equals 0. Yeah. Is it negative 3/4? Negative what? 4/3. Yeah. Be careful with that. That's why sometimes it's not a bad idea to write it out so we get them in the right one. Okay. Oh, there should have been a comma here too. Everybody okay with all that? Any questions? All right, then we're just gonna, I was gonna kind of let you work some, but we'll just work through the rest. That way I have plenty of time to give you your quiz back at the end. I need to set number 29 equal to 0. Do you want to move everything to the left or to the right? Left. Okay, so this will be 3x squared minus x squared. So it gives me 2x squared. Then, and you can mark them out as, okay, I use those. Then minus 8x, and then minus 42 equals 0. Can I start by doing 2 times 42 and looking for numbers? Can I? I can. Do you think that's the best thing to do? No, because the numbers get kind of big, right? So don't ever forget to look for your DCF. So we're going to factor out a what? 2. So 2, and then I get x squared minus 4x minus 21. Now this is fantastic news, because now from what the rest I'm factoring, a is 1. I don't have to do the multiply and the whole grouping thing and everything. I can now jump to 2 and then have my little parentheses, and that equals 0. And I know this is going to be x and x. This is negative, so the signs are opposite. I need 2 numbers that multiply to give me 21, combine to give me a negative 4. Mm, 7 and 3, yes. Because the only factors of, and if you're stuck there, like, I don't know, start writing them down. Go, all right, I got 1 and 21, not divisible by 2, divisible by 3, 3 and 7. Okay, not divisible by 4. You know, just start jotting them down instead of just staring at it. And, you know, all right, so, and which one? Let's see, 7 was negative, and then 3. Is this guy going to give me a 0? No. So my solutions, my roots, solutions, zeros, x-intercepts, all that, negative 3 and 7. Okay.
Is it possible for you to have negative, plus 7 and a negative 3?
No, because a plus 7 and negative 3 would still multiply to give me this, but it would have given me a positive 4 right there. Does that make sense? So when you know they're opposite, if this number is negative, then your bigger number has to be negative. Okay, good question. What else we got? All right, good. We got plenty of time to do this and get our quizzes back. All right, those are Z's. Hopefully they look better on your paper than they do up here. Can I factor out a GCF? Yes. Now, I did intend for this to be an equation, and it's not. So I couldn't solve it like it was before because it wasn't equal to anything. Now I can solve it. So what I can factor out a 6, just a 6. Yep. So then that leaves me with z to the 4th minus 5z squared plus 4 equals 0. A is 1. That's fantastic news. But this is z to the 4th, so be careful with what you're writing so you don't get sloppy on things and then confuse yourself. This would have to be z squared and z squared. This is positive, so the signs are the same. This is negative, so they're both negative. 2 numbers that multiply to give me 4, combine to give me 5. Yeah, 4 and 5, right? So, I'm sorry, 4 and 5. Oh my God, 4 and 1. You know what I meant. Whatever you said was right. And I could have put the 1 and the 4. It doesn't matter which order they're in. Can I factor this more? Yes. Now, this guy, he's still just a 6. But this is a difference of squares, right? So that can be z plus 2 and z minus 2. Can I factor this some more? Yes, because they are both perfect squares. And so this is going to be z plus what? 1 and z minus 1. And then it is fully factored. Is this guy going to give me a 0? No. Now, you can list out 4 zeros, and that's fine. It is also okay to say z is equal to plus or minus 2 and plus or minus 1. Okay, or you can list out the 4, however you would rather do it. It doesn't matter. There are times where one might be better than the other, but we'll talk about those for ourselves, not like for the answer to be right. What questions you got? Okay, so the rest of this is all in Delta Math. It was there yesterday, same thing, right? And let me give you your quizzes back.